usually within 2 days. Our speakers today are Nathan Pierce, Console Specialist with HashiCorp, and Mayur Badur, Senior Product Manager with Citrix. Feel free to reach out directly to the speakers via Twitter for any follow-up questions as well. And now let's get started. Over to you, Nathan.
Thanks, Karen. So I'm Nathan Pierce. Thank you for the introduction there. I work at HashiCorp. My primary focus is on Console, a magnificent control plane for doing fantastic service discovery and service mesh solutions across multiple platforms and architectures. Today, what we're going to talk about is how Console works with network infrastructure and supports automation of network technologies, but more importantly, across multi-cloud architectures. So we're gonna start off by just setting the scene with the problem that we've got to as a result of cloud and its agility and all of the wonderful things that it brought us, and the operational challenges that's brought. So we'll do a little bit of a dive into kind of DevOps, what that's done to the network and security kind of policy lifecycle management. It's created some unique challenges, and we hope that we can help show you a path forward and how to solve those challenges. We're going to hear a little bit about what Citrix has also done to kind of respond to those changing market conditions and the platforms that we need to operate around, the life cycle that we need to operate around today. And then we're just going to get into a demo. We're actually going to show you how to operate one of these new cloud kind of based patterns of keeping policy up to date automatically. So a little bit of a terminology kind of refresh there on that difference between task-based automation versus systems thinking and orchestrated systems. So yeah, again, questions, throw them in the Q&A. Happy to answer them as we go. We'll do our best, and we'll have a Q&A at the end as well. Thank you. So next slide. So let's get on to this first topic, understanding network infrastructure challenges with multi-cloud. I think everyone can probably remember when cloud first became a really big thing. It was all touted as it was going to save you money, and people learned very quickly it didn't save you money. It just made things able to happen faster. So it was this transformation between traditional static infrastructure, where I had to rack and stack and all those wonderful cold nights in data centers, to now these more dynamic and more agile infrastructures. People saw, again, costs go up dramatically because it released workloads that were inhibited by static infrastructure. Next slide. So the challenge of networking became very difficult, because instead of deploying a couple times a year and having static infrastructure that we had to then manage and configure in front of that, we now have these microservice, more agile workloads that are changing all the time. And we're doing things like A/B testing in production. We're doing them live, and we've got multiple versions of front ends and instances that need to communicate with each other. So how could we possibly network in a space like this and keep things not just interconnected, but securely interconnected? It's tricky. Next slide.
Yeah, absolutely, Nathan. We too see similar shifts from the application delivery and security perspective. We see a lot of customers now don't want to get locked into a particular cloud vendor, right? They want flexibility to move their workloads, be it from on-prem to any cloud or move across cloud, right? And as and when they make this transition, they are redesigning their apps as per the cloud design. So basically they can get the best performance and agility out of it, and they're modernizing their apps, right, for that agility purpose. When these customers are taking this distributed hybrid multi-cloud approach, security becomes very, very critical, and it's in top of the mind of everyone who's initiated this journey, right? And this brings a lots of importance to holistic observability, ability to troubleshoot or mitigate issues real time, and along with that, a centralized control to manage and maintain the entire infrastructure, right, from a single pane of glass becomes increasingly important in this changing landscape.
Absolutely. So let's talk about how we got there. DevOps was fantastic for many. It was about this reducing operational friction. I like to have this quick reset because over time, every fantastic terminology that comes out gets manipulated and goes off 7 different directions. Let's not even get started about SDN and all the different things that can mean today. But yeah, DevOps was all about reducing operational friction. How can I get my development environment and process through to production without insanity and craziness? How can we bring all that together? So let's just do a little bit of a recap of the spotlight that shone on network and security operations. So this was the original objective. This was the goal. How can I get the service creation that's productivity improving or revenue generating to the intended service consumer seamlessly and immediately, but without introducing risk? This is what the whole CI/CD, continuous integration and continuous deployment. However, next slide, please. The reality that we saw from a lot of this, continuous integration is that whole, I write code, I check it in a repository, automated tooling kicks off, and it does validation testing. If all the tests pass, then I'm allowed to merge that into the main branch, which kicks off more automation that produces an artifact. That artifact might be a binary, a framework, a container. It could be many things, but the difference here, the key difference here is that continuous delivery, the delivery of that artifact, of that binary or of that container, not the deployment, not to production. If you Google DevOps tooling, there's actually a great DevOps periodic table of tooling that shows the enormous industry that got built around this movement, but it was all focused on delivery, not that last step, continuous deployment into production. So let's dig into some of that. So the reality moving forward, what we got really was this continuous delivery, all of this automated testing. Another click, please. And then manual deployment. Click forward. Next. Yeah, so we've got the continuous delivery and then we've got the manual deployment. So this is where we still have our ticketing systems from our traditional operating model, but we have all this fantastic automation. So DevOps focused on like deployment teams, on server teams, on virtualization, containerization, all those things, but that still doesn't get me into production. That still doesn't get me firewall policies. That still doesn't get me web application firewall technologies and all that front of house kind of services and resilience. So next slide, thanks. Now that is largely as a result of an entire industry operating around CLI and GUI usage. So traditionally CLI, more recently GUI, that's how we set things up. So this ticketing system, like, you know, a service got deployed, now I need a change to be made. I create a ticket saying, these are the new servers I deployed, here's their IP addresses. How can I get them all updated and out into production? And that takes a lot of time. And it's not just time to execute, it's time till someone's available to start executing on that. I still talk to people now who have a delay time of 4+ weeks for a change because that person needs to be available to make the change in addition to the time it takes to make the change itself. So next slide, thanks. So really, I call this the third CD in CI/CD. We've got continuous delivery, continuous deployment is the goal, but really what we have is this continuous disappointment, which is the application teams that have created all of this service value that is not getting to its intended audience, the service consumer. That revenue generation is not happening or that productivity improving is not happening. Next slide. So really what we've done, click again, just let this one build out. Really what we've done is we've kicked this continuous disappointment down the road a little bit because the networking and security industries responded by automating themselves. Now, this is where I said at the beginning I was going to give a bit of a refresh on the difference between task-based automation versus systems thinking and orchestrated systems. You hear these wonderful stories about organizations like, you know, Netflix apparently has like 4 or 6, it changes every month, SREs that run the entire show. That's because no person is in the path of creation of value to consumption of value. They just run the system end to end. So we still have, for many organizations, this problem where there's all this automation in continuous delivery. We call that hurry up and wait, because there's still a ticketing system here. So in the end of this stream, we've had a lot of focus on people writing, you know, Python. A lot of the networking industries now learn how to like do some scripting, but it's a person running scripts. A person has to put variables in that scripts. So they've made themselves slightly more efficient, but we still have a ticketing system and a person that needs to run that script and then close out that ticket. A little bit faster, but not fast enough for the agility that cloud brought us. It's still not quick enough. Automated tasks, person serving, task-oriented, orchestrated system, end-to-end. Next slide, please. Now, the people love to beat up on ITIL here. I think that's unfair. I think ITIL had the right set of mind, creating reproducible patterns. That's still the goal. We want something sane and safe that we can reproduce, but we've got to get away from process of the person. I did all the steps that we documented and created that were right, and make those steps turn into a system, a orchestrated system that can support end to end. So the idea is still great. It's the way we implement ITIL that is the problem. Next slide, thanks. And getting there means getting away from these mechanisms of managing things. These are all human-centric mechanisms of tracking tasks and where things are and what's going on. And it's a hard one to let go. It's a cultural thing. We're not talking about replacing people here. We're talking about retasking people for greater productivity. So getting them off of being in the path of every change. And instead of having that, having them manage the process that does the change itself. Next slide. Great news is Consul fabulously fills that gap, and you're going to see a demonstration on how we do that today. It's pretty cool. All right, over to you.
So yeah, before I get into our console automation with Citrix ADC, let me give a quick overview on what Citrix ADC is for those who are new to Citrix ADC, and how the evolution of portfolio of our Citrix ADC has been for multi-cloud. So Citrix ADC is a primary advanced delivery and security controller that provides you comprehensive ability to manage your traffic. It does all right from load balancing your SSL traffic to SSL offloading and defining all this intelligent routing, traffic routing capabilities, all those layers and capabilities around responder, rewrite, and content switching policies, right? Along with that, it has also application optimization and caching features that can optimize the end user experience. Now, traditionally, ADC was available as a hardware appliance long time back, which we call as MPX. And then there was a multi-tenant hardware box, which we call as SDX. So this were the box which were dedicated for ADC. It can guarantee you a certain performance that meets your business requirement, right? It can guarantee you a certain amount of SSL transactions per second. So this were those initial days when you put this box and go to your data center, put it up, set it up. It requires a few days to get it up and start delivering your apps. But now in the software world, we have this virtual appliances. This is the virtual instance of our ADC, basically virtual machines that you can install it on hypervisor like Zen Server ESX in your private data center. Then we have a cloud-aware versions of this virtual appliance for respective different clouds, AWS, GCP, Azure. So this virtual instances of ADC are made cloud-aware and optimized for performing well in this respective cloud environment. Along with that, we have a containerized version of Citrix ADC called CPX. This is for your microservice Kubernetes-based deployments, which can be used for manage both north-south, east-west traffic. And the latest one is the bare metal kind of a Linux version, a native Linux version where ADC runs as a process and on your native Linux machine. So you get a choice of choosing whichever form factor suits you in this your hybrid multi-cloud journey. And one thing that comes out very well is whichever flavor you go for, you get all the same functionality and capabilities, primarily because of the single software code base that we have across these different versions, right? So in that way, you are guaranteed a operational consistency across your infrastructure. Along with that, we also have something called pool licensing, where you can procure a certain bandwidth of license in terms of you can procure a certain bandwidth or vCPU-based license, and you can use that license to use it to license any of these versions, or even you can move around the license for any of these versions. Yeah. Talking about security, as I mentioned, right, with your distributed infrastructure, your surface area for attacks just increases drastically. And that's why we have our inbuilt security capabilities as part of the same Citrix ADC. So we have all these L3 to L7 security capabilities that can help you to provide a layered protection to your apps and APIs. And again, this security capabilities, be it WAF, bot, given it is all same code base, so you can expect the same consistent security, be it using, even if you are using, even if you have deployed your apps on on-prem or any of the clouds. right? Talking of some major capabilities in security, we have a web application firewall capabilities that protects you from all top 10 OWASP threats. Again, it employs hybrid learning model where it includes signatures to filter basic attacks. It can also employ app learning model to mitigate advanced D0 attacks. Then we have bot mitigation capabilities to block the spots based on IP, geolocation, IP reputation, API protection features from token-based authentication to rate limiting. And, and more importantly, we have this centralized control and visibility that you get with what we have a Citrix ADM. So you get to observe all your API performance, any kind of API abuse through a single pane of glass with our Citrix ADM. And it also employs machine learning techniques to identify any sophisticated attacks that mimics human behavior. So with Citrix ADC, you get load balancing as well as security capabilities all in one go. Now, over the past recent years, right, this virtual machines, virtual versions, editions of Citrix ADC gets more prominent as more and more deployments move towards cloud. And with that, there is an increasing need of ADC automation, right? Because that's how they want to realize the agility goals. It becomes very, very important for our customers to automate ADC. And that's where we partner with HashiCorp heavily on how can we simplify this ADC journey, automation journey from day 0 to day 2 or day n, right? So starting off with day 0, you can have automated deployments of your virtual editions of ADC on any of the cloud like AWS, Azure, GCP through our Terraform cloud scripts. So you can set it up your AWS infrastructure, like defined subnets, security groups, all as part of the Terraform itself. Then it will provision the VPX, ADC VPX for you, and then you can log in and start with the configurations. Post the deployment, you want to set up a basic networking configurations, you want to license your VPX, you want to create admin partitions, define VLANs, all that can be done declaratively with the help of a Terraform provider for Citrix that we have, right? And this same Terraform provider can be used to create application configurations, right? Once you are ready to expose your app, you can create a load balancing vServer. You can define how you want to handle that traffic to that load balancing server, responder request, rewrite request, SSL ciphers, all that can be done in a very declarative and infrastructure as a code fashion, all through Terraform, right? So imagine all your ADC configs are written as part of Terraform resources, stored in GitHub, and it's being managed similarly how you would manage your application code. Along with that, we also have HashiCorp Vault integration. So if you're going for our CPX, then you can use our Vault to retrieve ADC credentials from HashiCorp Vault. So all this is done for day 0 and day 1. Coming to day 2, right? When there are a lot of changes happening at the backend application teams, you're scaling up your apps, you're scaling down your apps based on the user traffic patterns, or you might want to do some kind of A/B testing, or want to roll out new different continuous deployment techniques. For that, we have again a customized Terraform solution to facilitate blue-green deployments. So your ADC, Citrix ADC can help you to do a blue-green kind of deployments for your applications, and also to dynamically update your backend services on Citrix ADC. What we have is Consul-Terraform-Sync module for our network infrastructure automation, and that we are going to deep dive in the rest of this session. So a couple of things on Terraform. As I mentioned, our Citrix ADC Terraform provider is available in HashiCorp registry. You can use it to configure it on any of the cloud, right? Also, along with that, you can deploy your ADC within standalone, HA, and everything using our Terraform cloud script, which is available in our GitHub. Now, as part of this session, we are going to focus on day 2, primarily because day 0, the deployment of ADC is one-time process. You won't deploy ADCs often unless you are spinning up a new data center, region, or new VPCs. So it's a one-time process. Again, then you set up a network configurations once based on your architecture design. Then you set up your applications, and you don't touch your application configurations often unless you want to make drastic change to your security policies or LB protocols and all. That's once you have defined it well and good. Now, what happens is once you set it up, the long tail of pain basically comes with day 2, where a lot of churning changes are happening at your backend from your application teams, right? Who want to push out releases frequently, or who are scaling up or down our apps. And that's where ADC needs automation. And that's where Citrix ADC Consul-Terraform-Sync module for NIA comes up very, very handy, which we'll be looking in detail.
Yeah, this is a really important point you're raising here, and just the clarity of these different models. They're complementary, but they're not directly required and reliant on each other. So you hear that term infrastructure as code. That's what we're talking about on the left-hand side here. Like, how can I provision? How can I create a virtual ADC instance and do it in a templatized way that is reproducible? I love the term reproducible operations, because if it's reproducible, if something goes wrong, the old model, when we manually build things, if something went wrong, I was troubleshooting a known bad state as my source to get back to a good state. That is the most horrible experience of trying to get something good up and running again. Whereas if I've used something like an infrastructure as code model, something that Terraform just excels at, when things go bad, I nuke and repave. That's just a fun term to say in general, but nuking and repaving, I know that my last configuration was good, that I checked into my infrastructure as code repository. So why try work out what happened? Maybe someone of the old mindset logged in and made some changes and broke everything. I'm just going to nuke it and repave straight over the top, and I'm running again. And because I'm using a reproducible operational pattern like infrastructure as code, and I've got a tool like Terraform, I just know that that's going to work again. It always works because that's what we tested and rolled out to production. So that is the day zero kind of day one, which it's a change in workload here, linking back to like what cloud did to this industry. That used to be the entire job for network and security people. It was always about getting things up and running because we didn't do rollouts all the time. We didn't have continuous integration. So once, as a network engineer working for a customer, I would get that up and running and probably not touch that device again, maybe for a year. Whereas now that's actually a small part of the workload in network and security operations because things are changing all of the time. That's that long tail, that day to operations. So suddenly we're heavily involved in the technology's life cycle as things are changing with the app all the time. And that's the bit that we want to focus on today. Now, the operational effort for a technology is all in the post-deployment time of all of the A/B testing and all of the A/B testing, that alone is a big one. I mean, that's a huge one in itself. And just running parallel kind of versions. So they're not required for each other. You can do this day two solution, even if you did manually build your technology. Don't think you need like a greenfield data center to start looking at this. You absolutely don't. You can start with your existing technology and use this Consul-Terraform solution today. But by all means, if you've got the opportunity to build anything new, absolutely look at infrastructure as code as a mechanism to do it. It will save you a lot of time and eliminate a lot of fear and pain as well.
Yep, absolutely, Nathan. So going to deep dive on this, how Consul and Consul-Terraform-Sync help us solving D2 operational challenges with Citrix ADC. So quickly briefing upon the customer problem that we have seen often among our customer bases, they often come up with that they are flooded with the request with the application teams to make small minor changes on updating their instances, right? And this is often, IT teams, networking, ADC admins are a centralized team. And they are exposing multiple apps. They are taking care of different teams of your organization. Now, any time when the backend app teams are making any changes to their apps, they have to create a Jira ticket or some sort of a ticket to get that change done at the ADC level. And that's where Nathan talked about, right? It could take 4 weeks of time maybe to get that change propagated and get it done. And that's hindered the agility of the organization, of the teams, even the self-service goals that most of the DevOps team aspire for, right? along with that, whenever that ADC team is making change, it could be a manual one. So this manual change is prone to misconfigurations because now you are trying to make sure that the IP, the port info, all the services info, you have got it correct, right? Even if you are using Terraform, right, to drive that change, it's a very small task-based or focused task-based automation that you need to make sure you need to get it right in your production environment. So it does come with certain degree of risk, right? And as you can figure out, this current process is not scalable. Basically, network and security teams cannot scale to so many requests that comes from application teams. Yeah. So,
I'm glad you mentioned scale there. I kept talking about A/B testing and forgetting the whole scale thing. Sadly, I've seen quite a few organizations trigger their own outage because maybe they released a new front end of their application. I've seen some banking organizations do this, and then they do a mail out to their entire customer base saying, hey, log in and check out our new front end, and it took out their infrastructure. Now, the server teams themselves had implemented some of these more modern technologies of scale groups where they could very quickly just say, you know what, we need to go from 5 front-end servers to like 10 super fast. But because they hadn't done this level of orchestration of all of the systems through the continuous deployment, they'd only focused on the delivery side of the chain and the scale group. They increased those servers, but all those servers were running at like 10% utilization because then they had to open a ticket to get someone to respond to the network and security technologies in front of it. That's that last mile of data paid. So I'm glad you mentioned scale there. Scale is a huge bit because this agility we get from cloud, that means we should be running things leaner, not like the old days when everything was built in an on-prem data center. So we had to scale for the worst case scenario, which meant buy more servers than you needed just in case. And most of them would be idling most of the time because most of the time is not at the worst day of the year. One of the greatest values of cloud and that agility is I can scale down when I'm not needing it. But that is only safe to do if I am orchestrating the systems in front of that scale group to respond at the same time, to respond immediately, because that's the difference between slow performance for a minute or two until we up that scale group versus an outage because we can't get load to the new servers we created in the scale group.
Yep. And exactly to deal with this challenge, HashiCorp came up with network infrastructure automation solution, primarily to enable dynamic updates to your networking infrastructure devices, which are kind of triggered by your backend service changes. Specific to ADC, we can dynamically update your application service configurations, which are services configuration in ADC, which are synced with Consul-Terraform-Sync module. So we have our integration, the ADC Consul-Terraform-Sync modules available in the HashiCorp registry, and we will show you how these modules are used to bring about this, to address this use case. I'll move on to the next slide where we'll know how this actually is, how this dynamic updates is achieved, right? So here we have, let's say Citrix, here we have a Citrix ADC that is front-ending 2 apps, App A, App B, and we have 2 load balancing servers respectively for that. So users are able to, based on the user traffic, it gets routed to the right app and users are able to access the applications. Now, let's say based on app performance or the user traffic, you want to increase one more instance of A, or you want to decrease or you want to destroy a particular instance of application B, right? So now that changes had to be propagated to ADC so that user traffic is appropriate. Now, usually the process is, as we mentioned, is manual, but now let's say we have a NIA solution in front. So NIA, Network Infrastructure Automation Solution, comprises of 3 components here: Consul, Consul-Terraform-Sync, and the Terraform, right? Consul acts as a service discovery tool for your backend infrastructure. So it has the visibility of all the changes that is happening over here, and it is being captured in the Consul catalog, which actually act as a single source, a reliable source of truth to push or to drive any kind of changes to your other infrastructure that you might be having. So in this case, that Consul acts as an event trigger whenever there is a change in the Consul catalog. then Consul-Terraform-Sync basically picks up that change and auto-generates ADC Terraform configuration files, right? So the Terraform resources, the configuration files get auto-generated and gets applied to your Citrix ADC. So Citrix ADC is then updated with those configuration. It is now made aware that there is a new service for this particular app A, and this service, one instance of this application can be taken into maintenance mode, so no other user request gone, and then you will see that the user traffic is appropriately diverting traffic to the new instances.
Absolutely. If I could just clarify one bit of the console part, I've probably been a little vague on the console working here. So basically that representation there is the console cluster. Typically we deploy a console binary with the services. So in that scale group image, you would have a console binary. That binary is locally measuring the health of that application, each instance, and is reporting that back to the server cluster. So you typically have a 3 all active cluster. They have a consensus algorithm. They're always voting. This is the current state. That is your source of truth. And sorry to jump in there, but you hit a key term that's really important. The one thing missing from this task-based automation is a reliable source of truth that could have replaced the human inputs. I'm getting a ticket through with some IP addresses and I'm inputting that into my Python script or my playbook or whatever tool that I was using, but I'm still the problem. I'm in the way. What's been lacking for most security and network automation is a reliable source of truth and an event trigger that occurs when that source of truth changes. That is the part that Consul delivers. Consul is this all-seeing, all-knowing service catalog, because those agents are updating constantly. This is what's going on. There's a gossip protocol. They're all aware of the health and the state. And basically, Consul-Terraform-Sync's role here is to subscribe to a service in that catalog. And anytime any change happens, the state of that service is propagated through to Consul-Terraform-Sync. So Consul-Terraform-Sync is now running Terraform. You're not giving it the variables that would have made the change. Consul that knows what the change is inputting those variables via the Consul-Terraform-Sync agent. Now that, again, CTS, Consul-Terraform-Sync, is just a binary. You just install that on the server, you tell it where the console catalog is, you tell it what service you're interested in, because we might just have, the web front end that needs to go into one LD policy, but then another system in another. So we differentiate what we want to trigger on, and then you step back. You now have that orchestrated system, because the event trigger and running CTS and that all executing in a second is absolutely faster than any service-based ticket system, and waiting for someone to be available to run that. And now I've got a solution here where the policy doesn't need to be touched every time, just the elements upon which the policy is affecting the scale group, the service. That's the only bit that we're touching in each individual change here. So this is that long tail, that day two long tail of pain that we were talking about a little bit earlier. Consul has the catalog. Consul-Terraform-Sync is merely the conduit of the catalog change for the service I'm interested in. And Terraform, one of the most used technologies out there for infrastructure as code, already has the Terraform providers for talking to Citrix ADC. So it's trivial for that to just say, oh, I'm going to update your server group now from these 3 to those 7. Have a nice day. Really elegant, not a lot of moving parts kind of solution here. And then that's what it is that we're showing you. So hopefully that helps understand like the console side. It's a client server kind of pair. An agent goes on the server and then it has its database, its catalog that runs on the server element of console.
Thank you. Thanks, Nathan, for clarifying on that. So now let's see this in action. So we will move on to demo. And for the demo, I'm going to use the same ADC NIA modules that we have in registry. Okay, so moving on to demo, you can see that currently I have my console installed on the local server, and I don't have any services, as you see in my screen. Right. Now I'm going to log into our automation controller here. This is where you need to have the Consul-Terraform-Sync binary, and along with that, the ADC integration modules, right? And what we'll do is we'll look into some of the important files here, which will be of particular importance when you go and try this out. So first one is the config.htcl. Now this is where you define the console address, you can define the console services, and And in the task section, you can see here the services that you want the Consul-Terraform-Sync to subscribe to. As Nathan mentioned, right, you might have so many services or 50 or hundreds of services, but you just want to, let's say, integrate a couple of services for Citrix with Citrix ADC. So you need to mention that as part of this services list here. Then you also define the provider that you want to use. So here we want to automate the configuration Citrix ADC. That's why we are using the Citrix ADC Terraform provider, whose details are given below. So primarily when to use this, you have to edit this file for your own services and the providers that you will be using. And now, then there is another file that is of importance, is the main.tf. Okay, so the main.tf file is not something that you need to touch upon, but here's the file that we are defining what all Terraform resources, what are Citrix ADC resources that will be created on the fly, right, by the Consul-Terraform-Sync. So you can see we are creating a Citrix ADC resource called service group. Then we are also creating a Citrix ADC resource called service group member binding. So the service group is basically a collection of instances that corresponds to a particular application. And then each instance of that application has to bind it to that service group. Now, if you see this a particular file, we have put in intelligence here. So for all the services that you have subscribed, it will go and check if there is an existing service group, then it will attach to it. Else it will create a new group member and attach to a service group. So all this has been written here. You can use this file as is, but if you want to modify and extend this for new use cases, then this is a file of primary interest to you as well, because this will define all the runtime Terraform resources that you want to create. Along with that, this is a variables file. Again, this gets auto-generated. So as and when new Consul catalog changes are being communicated to Consul-Terraform-Sync, then it is going to populate this variables file with your latest state of the services, be it IP, port, any kind of metadata description, right? So this will get auto-generated whenever this task is run.
Yeah, this is the input we discussed earlier that you would typically have had to run yourself. This is not a specific Terraform thing. This is just tends to be how most automation of network and security equipment runs. We automate the individual steps we used to run, but we still have to tell that automation script, these are the things you're going to change in that. So this is that variables input that you would have had to run yourself, but now Consul is going to provide all those IP addresses and ports and information that the technology needs on our behalf. We just have to maintain Consul-Terraform-Sync and make sure that that's in a nice healthy state and everything's fantastic.
Makes sense. So now for the demo purpose, what we're going to do is we are going to spin up new services. So we have a mechanism to do that. So I'm going to spin up few services, and you will see that now I have a counting service, which has 2 instances. You can see Consul has already picked up that. You can see the IP, port info, all that. And now we will see how Consul-Terraform-Sync works, but usually the Consul-Terraform-Sync binary is installed in this automation controller. It is put into the execution path, and this daemon would be running. Just for the demo purpose, I will show you how this is manually triggered. And in next instance, we'll see how this is done automatically. So here we are just pointing it to the config.html. So we are just manually triggering this for this one. And you'll see that Consul-Terraform-Sync picks up. It has started creating the service group binding for this counting app. It is creating service group for the counting app, right? So it is creating all those Terraform resources. And once I log into my Citrix ADC, once you do show me the service groups, you can see a new service group would have been created automatically. Yeah, there's a counting service group created by the Consul, and we'll get to see the members also. So there are 2 members, 2 instances. You can see the IP port and confirm it with your instances. So again, I will trigger this one more. We will spin up another new service. You can see that again, in this time, Consul-Terraform-Sync, we didn't run it because that is already running. It picked up this change, and as soon as this new service was picked up by Consul, it started executing this task, which we had seen in that config.html. Then it started creating again a service group member binding. It started creating service group with ADC_SVC. So yeah, here is the new app that we are trying to expose. There's a new instance. And all those changes have already been made it to Citrix ADC in the split of a second. So once I log in, I can see there is another service group with ADC_SVC here. And you can see there is only one instance as part of this service group, right? So you would have noticed there was no manual intervention required. As soon as this new service came up, maybe in max a second or even less than a second, Consul-Terraform-Sync picked it up, generated Terraform resources for it, and you can see the ADC has all those info and been configured properly. Now, also, if any instance goes down, right, and if any instance is brought down or there are issues with its health, so I'm going to simulate that scenario here. Yeah, so once I have taken down a particular instance, you can see Consul-Terraform-Sync is kind of triggering a Terraform to destroy those resources. You can see the destroy service group binding. So both the services and the service group are destroyed. And if I log into my Citrix ADC, you can see that there are no such service group or service group members because they have all been destroyed at the back end.
So there's something I really want to just call out there that is often not talked about in automation. It's really easy to write some scripts to create stuff. Lifecycle management is a problem for many. In fact, there was an organization I talked to earlier this year where it takes them 6 months to update a security policy because they have to sit down and evaluate every single rule and what the impact might be. Because things were deployed, but when those services were decommissioned, the security policies were not part of that decommissioning process. So as time goes on, the complexity just increases and increases until you're at the point where you've got hundreds of thousands of security policy rules that now need to be evaluated. And they're in a bad place now because how do you get out of that problem? You are now stuck with every change, and it takes them up to 6 months to do a firewall policy change now to get around that, because as you just witnessed in this demonstration, when the service was decommissioned, Consul-Terraform-Sync pulled what it had created back out. It created a service-specific resource, and then it removed that specific resource when it was no longer required. That lifecycle management is extremely valuable. Otherwise, over the time, you just get bloated configurations, and it's too dangerous to just go through, start deleting something when who knows what else could have been relying on that.
Thanks, Nathan, on that. Other thing, so in the demo we just showed you, right, how can you increase and how can you add on to the instance, or how you can delete an instance or dynamically update the services configuration part. But the same setup can be extended to more other scenarios of Citrix ADC, right? You can spin up a new load balancing vServer as part of using the Consul-Terraform-Sync, right? Imagine like you want to expose a new app, then if you have a predefined, or your IT or ADC or networking teams can give a predefined template of all your Terraform configurations on what kind of global policies that you want to have, what kind of WAF or bot mitigation policies that you want to have SSL ciphers that have been recommended. So all those can be a pre-approved template from your ADC team, and you can just put it as part of that our ADC modules. And when a new app has been introduced, you can use that one to dynamically create a load balancing vServer, right? And it will attach it to your backend services. And it will also adhere to all the compliance, the security policies, the global policies that your particular Citrix ADC VPX instance is having. So that way you can make this much more catering to other use cases for your particular needs.
Yeah, well said. That so hopefully everyone's seeing from this session, like the key element here was this integration of reliable source of truth, that state, that service catalog, through to execution, using that state to affect change in a safe, reproducible, orchestrated system. That doesn't just give you faster time to market. It's time to react. Do I need to change the scale group? Do I need to get this app offline as soon as possible? And having the infrastructure automatically reflect that change of what's going on in the back end is high value. So then people who look after network and security technologies, those NetOps and SecOps people, can now go back to actually doing policy improvement and tuning and validation and evaluation versus constantly reacting to changes that might be going on in the infrastructure. So it's much more forward-thinking work and productive work versus constantly at the end of a queue of just add this IP, remove this IP, which just that hurts to even say out loud.
Makes sense, Nathan. Let's see if we have got any questions.
Yes, thanks, Nathan, Mayur. I'd like to open up for any questions. We have had a few come in, but please feel free to type any additional questions in the Q&A feature at the bottom of your screen. And let's see, the first question that we have, can ADC CTS solution be extended to other use cases, such as create new load balancing servers on the fly runtime? Who would like to take that? That you,
yeah.
Mayur?
Yeah, Karen. Yes, so I briefly touched upon it, right? Whatever Terraform can do, whatever Terraform can configure for your Citrix ADC, all that can be made as part of your Consul-Terraform-Sync solution. It's just, once you download our solution from our repo, then you need to have certain resources file ready for all the predefined configurations that you want to have, right? The kind of SSL ciphers that you want to use, the kind of LPV server you want to have, HTTP, HTTPS, all those predetermined things is something you need to make it available as part of resource. And then if you want to create a new entity, right? So if you remember in my main.tf file, I had only two type of resources, service group and service group member binding. But let's say if you want to spin up a new load balancing vServer, then you need to edit that main.tf to spin up that load balancing vServer on the fly. But to answer your question, yes, we can address many more use cases, primarily because ADC can be configured by a Terraform for different scenarios. So
yeah, Consul-Terraform-Sync has a concept of because Terraform manages its own state. It knows what hasn't been created and what has been created. So if you created that Terraform definition to create the Citrix ADC and then configure it on top of that, the next time a change happens in the state, it's not trying to rerun all of that. It knows I already built the ADC. I know it's right there. I know the only thing I'm touching right now is that service group. So from then on, it's just going to touch that one part. So you absolutely can build the whole workflow into there. The cool bit of that one is if anything happened and you were like, I somehow managed to do a mistake and break it, you can just nuke that virtual ADC. And the next time it runs, it's going to put it back. It's going to see that it's not there. So yeah, you can absolutely put more complexity into that. We just showed like the main like pain point for people of just updating, the service groups over time. We've got some examples where people didn't just bake the automation of creating the Citrix virtual ADC into that pipeline. They also touched other technologies. So for example, register that with the DNS system for the virtual address on the front, and also go and generate a new certificate from Let's Encrypt and install that on the pod. So you can actually have a full chain for the entire life cycle. Again, Terraform has providers to do all of these things. So if there's a Terraform provider for it, yes, it can be part of that pipeline. But again, more importantly, if you decommission that service, it knows I got to now relinquish that DNS name, I got to relinquish that certificate, I got to get rid of this ADC, and I'll repurpose that license for some other project I'm working on right now. So actually, the more you put into the system, the more value you get. But what we showed today, which was great value, not having to do ticket-based workflows anymore, you get just by touching the service group. So you don't have to go all in to get value from day one on this.
Thanks, Nathan. We have one more question. If I have ADC, can I use the same as Ingress, or should it be planned as ADC plus Ingress separate deployment?
Yeah, I can take that, Karen. Yeah, you can use Citrix ADC as an ingress for your Kubernetes or microservice-based deployment. You can use the same ADC as an ingress, and all those capabilities, L3 to L7 capabilities, can be as part of that ingress. So.
And I think we have one final question. I think this has been, just wanted to go through this again. The example shown assumes predefined service names. Is there a way to dynamically stand up resources for new services that aren't explicitly defined ahead of time? I can do this with Fabio LB, wondering if this can replace that same use case.
Okay, I am trying to remember if this was in the last release where we did this, or it's coming in the next one, but we're working on support for wildcard service names. So you don't have to, you do a regex-based pattern match. So you can say if it has a prefix of X, I want you to assume this is going to be front end, or maybe if it has a certain tag, because when you register services with Consul, you actually have tags that you can inject on that as well that will end up in the service catalog, and metadata as well, key value pairs. You can append loads of information. We don't just keep IP addresses and ports in the service catalog with Consul. It's a lot of information about the service as well. So we can configure Consul-Terraform-Sync to be aware of that and say, you know what, if the service name starts with X because of this regex max and it has this tag, I think it actually just build a whole new policy on the Citrix ADC and create a pool and deploy that one as well. So yes, you can specifically declare the service names, but we also have the ability to match against patterns as well. That's what I was trying to say.
Thanks, Nathan. I think that's all the questions that we have at this moment in time. And I think we've made very, very good time. So I'd like to thank you, Nathan and Mayur, for a great session. I think maybe there's some resources would you like to run through before we sign off today? Mayur, would you like to run through the resources that are available?
Yeah. Yep. So yeah, here is some of the solutions that we have made with HashiCorp. So you can check out our partners/tech Citrix. On HashiCorp, you'll get all on Terraform, Consul, Vault. This is the Consul-Terraform-Sync 0.4 for Terraform Cloud. This is basically the Consul announcement that HashiCorp made. Regarding Citrix ADC, the demo that we showed, that CTS modules for NIA is available here in HashiCorp registry. Along with that, the cloud deployments that we talked about, all of you, let's say if you want to deploy ADC VPX in AWS, in Azure or GCP, we have all of those Terraform cloud scripts available in GitHub. So you can clone this repo and use it. Our ADC Terraform provider, again, is also available in HashiCorp registry. So you don't have to download it. You can just use it with 4 lines of or 5 lines of code as part of your automation controller. And again, for day 2 operations, we defined a solution for how can you configure blueprint deployments for your applications using Citrix ADC content switching capabilities, right? So here is a very good example of how you can integrate Citrix ADC all using Terraform with Azure pipelines, with GitOps workflow, and again, it's kind of orchestrated or highly integrated system on whenever a new application changes that you want to roll out, ADC can configure to do a blueprint sort of deployment, or even canary sort of deployment. So this is again solution available in our GitHub. So do check that out. So yeah, these are the primary ADC resources.
Thanks again, Mayur, and thank you, Nathan, for a really informative session today. The session has been recorded and will be sent out after the webinar, usually within 2 days. So, and also thank you to the audience. I hope everyone enjoyed today's webinar and has a better understanding of dynamic networking with Consul-Terraform-Sync for Terraform Enterprise and Citrix ADC. And finally, I'll send an email again to everyone who registered with the recording link. Have a great day. Goodbye to everyone.